Okay, so if we have the same charges in the metal and the non-metal, we are going to cross the charges anyways, and in this case we can simplify them. For example, if we have magnesium and oxygen, the magnesium is 2 plus because it belongs in group 2. The oxygen is going to come to negative because it's going to get 2 electrons. We cross these charges, okay, and we are going to have magnesium 2, oxygen 2. But since we can simplify these, the formula, the actual formula for magnesium oxide is MgO. Okay, so that is going to be the magnesium oxide. The same if we need to do another one. For example, if we have aluminum and we have chlorine. Or let's do another one. Let's not do chlorine. Let's do fluorine, because there is a, with the aluminum chloride, there is a problem. So aluminum and fluorine. Aluminum has 3 electrons, yes? Because it belongs in group 3, so it's going to have 3 electrons in the last level. The fluorine has how many? 7. So I'm going to put 7 electrons here, but we are going to put them different. Do you understand that I'm only putting the last level of electrons? Because the last level of electrons are only the ones that are going to get involved in the bonding. Okay? So how many electrons needs to give away the aluminum to be stable? 3. So the aluminum is going to become aluminum 3 plus. I don't care how many the fluorine gives or the fluorine needs. I care only how many the aluminum needs to give away. Yes? And it's going to be positive 3 because there are going to be 3 electrons that were balanced, the protons before, but now they are not anymore. Okay? And as I always say, giving away is a good thing, so that is becoming positive. Okay, so how much or how many electrons does the fluorine need? 1. So the fluorine is going to become what? Negative. Negative what? 1. So I put only the negative sign, yes? Which is going to be the formula for this? Al F3. Because I take this one, I don't see my mouse now. I take this one and I pass it here, and I take this negative 1 and I pass it here. Be careful, because these numbers do not carry any sign. That refer only to the amount of atoms that I have in the formula, and an amount of atoms cannot be negative. Yes? So they are always positive. So we cross the numbers without the sign. Is that clear? Now, how do we represent that with what we call Lewis structure or the dots and crosses? Well, the aluminum is going to be empty, yes? Yes. Because the last level, it had electrons, but it doesn't have anymore. The charge is going to be the same charge as the electrons that it lost, 3 positive. And then we have the fluorine, and always we need to show the amount of electrons present. 1, 2, 3, 4, 5, 6, 7, and the last one is one of the ones that came from the aluminum. So we have a negative charge here. Yes, this extra electron gives the negative charge there. But there is something missing here. We need to what? Balance the charges, yes? So if I have 3 positive here, I need to show that this fluorine that now I call fluoride because it's negative, it's going to be 3 times. How do I do it? Where do I put that 3?
Right after, before you started it. Yeah.
Before the bracket. Yeah. That means 1 aluminum balanced 3 fluoride atoms. Okay, or 3 fluoride ions. In this case, we can name also the compounds, and we did that in the worksheet. How do we call this thing here? This one.
The name?
Magnesium
oxide.
magnesium oxide. Okay? And now we can name this two, which is going to be what?
Aluminum fluoride.
Aluminum fluoride. Okay? Remember that this one changes the suffix to ide, and this one doesn't change. So it's going to be aluminum, or aluminium in British. Okay? Aluminum fluoride. Yes? So far, so good? Okay. The only thing that we didn't cover the other day was when we have an transition metal. So pay attention, because this is going to be a little bit more complicated. It's not that we do not have the information. They have to provide us with the information, with some information. Okay, so we are going to see how it works. First, we have, let's say we have iron and we have oxygen. The problem is that the iron is a transition metal. The transition metals have the characteristic of putting different amount of atoms on the table for the bonding. In other words, they sometimes lose a certain amount of electrons, sometimes they lose a different amount of electrons. And it's very difficult for us to know it, and you are not supposed to know it by heart, okay? But we are going to work knowing the amount of electrons that they lose, yes, always, or knowing the name that is going to give us the amount of electrons that they lose. When I give you the example, you are going to understand what I'm talking about. I'm going to stop this and begin.